Hello, I'm Ângela. I'm from Portugal and I'm a researcher from CIET in Institute of Engineering of Porto and PhD student in Vigo. Our work is a stability study of copper oxide nanofluids in water for different sonication times. Due to the physical properties of nanoparticles and their tendency to aggregate and form clusters, the stability of nanofluids is controversial and demanding. Different techniques are used to improve stability of nanofluids. Sonication with probe has been shown better stability when compared with other methods. Thus, following our study, in this work, the stability of copper oxide, 14 nanometers, nanoparticles in water is studied. As not to mask the effect of nanoparticles, the experimental data were carried out without addition of surfactants. The nanofluids were prepared with copper oxide nanoparticles and as base fluid milky water. 0.02% CO1 nanofluids in water were prepared and homogenized with 10 minutes of magnetic agitation at 500 RPM, followed by intensive ultrasound vibration from a bundling sonopulse apparatus equipped with a titanium flat type TT13 of 13 mm diameter. Different sonication time was applied at 10% of maximum power. To prevent overheating, the sample containing flask was immersed in an ice bath. The stability of the nanofluids was determined by a UV absorbance spectroscopy and visual observation. The measurements were carried out for 1 hour, 2 hours, 3 hours, 24 hours, 48 hours, and so on, every 24 hours until constant absorption or no absorption. The samples were very opaque, so to be possible reading the absorbance were diluted 10 times. In figure 2, it's possible to observe that for 1 hour of sonication, the behavior is more stable when compared with other sonication times. It means that preserve the initial concentration for a longer time and thus the nanoparticles in suspension. Figure 3 shows that as the sonication time increases until a certain time, the absorbance increases. That is, the absorbance is greater when the concentration of nanoparticles in suspension is greater. Thus, higher absorbance corresponds to the maximum sonication time, is the optimal time. As conclusions, visual over time the deposition of CO1 nanoparticles was verified, which corroborates the results obtained by reading absorbance. The nanofluid that showed the best stability was sonicated for 1 hour. Thank you to listening me. I'm ready for your questions.